All right, here we go. Welcome back to College Algebra Final Exam Prep. So here we go with a logarithmic equation. All right, so I hope this one works out. I wrote this one myself, so we'll see. We have log base 6, p minus 7. Okay. Let's go ahead and get a bold color here. A contrast color, I should say. So we have log base 6 of p minus 7. All right, we have log base 6 of p plus 2. And this is equal to, I believe, 2. There it is. Okay. So with logarithms, there's a couple of rules of logarithms that you have to know for the rest of your life, no matter who is watching this. And that's log any base, okay, any base down here. And that's log of a plus log of b. Log of a over b is equal to log of a minus the log of b. And log of a to the r is equal to r times log a. Right? There's a couple more rules for logarithms that you might know for the rest of your life, depending on the school and the program you're in, but these are your basic 3 that you have to know forever. Okay, so what we're going to do here is we're going to use this first rule, but we're going to go backwards. We're going to use it this way. So we have log of a plus log of b. That's going to be log of p minus 7, p plus 2. Okay, equals 2. Oh, by the way, just as an aside, log of a plus b means you're in a dead end. There's nothing you can do with this. Okay, do not ever do that. That's not a rule. You, your teacher, everybody will be most unhappy if you do that. Okay. So going back to the correct way, okay, we're going to say, well, this is going to be log base 6 of, we have p squared, right, minus 7p plus 2p minus 14 is equal to 2. Okay, so here we have log base 6 of p squared minus 5p minus 14 is equal to 2. Okay. Now, what we have to do here is we have to take the anti-log of this. We have to get rid of the log because I've got variables inside the logarithm. The way you get them out is you take the anti-log. Okay. So we're going to raise each side to the same base, right? We're equating the exponents. When you first did your unit on logarithms, you probably had a lot of problems where you equated exponents. We're doing it in reverse now. Okay. So we're unlogifying both sides. Don't use that word, I made it up. Okay, equals 30. Nope, that's a 14, 36. Okay, we're going to subtract 36 from each side, and we end up with p squared minus 5p, and I believe, right, that's minus 50 is equal to 0. I think you can factor this, right? That's going to be, we need a thing of 5 here, so let's see what that's going to do. That's going to be like minus 10, and p plus 5 equals 0. Right, that's minus 10 plus 5, minus 5, negative 50. I think we're okay. Okay, so from here, we're going to say p minus 10 equals 0, or p plus 5 equals 0. That's your 0 factor principle. Okay, you can only do that with 0. Don't do it with like 12 or anything. So we have p is equal to 10, or p is equal to negative 5. Now, you're not done. Okay, there are 3 types of functions so far that you have to go back and check. Right, and those are logarithmic. Okay, those are rational, and those are radical. Specifically, if you have an even root, like a square root or a fourth root or something like that, you have to go back to the original, go back to original. Go back to the original problem statement and check these numbers to make sure they actually work. because with rational, you can get like division by 0. You can get an answer that makes you divide by 0. It's not really a solution. Radical, they can make you take the square root of a negative number. Not really a solution. Logarithm, you can't take the logarithm of 0 or a negative number. Not, in college algebra. Someday you may learn how to do that with complex. But not with 0, but negatives. Okay. So what we're going to do is we're going to plug in. We're going to see, well, back to my original problem. Here is the original problem. If I plug 10 in here, does it look like it's going to work? Well, 10 minus 7 is something. Okay. And 10 plus 2 is something. Okay, we got it. So they're both positive numbers. This one checks out. Okay. If I plug in negative numbers, right? If I plug in -5, that ain't going to work. If I plug in -5, that ain't going to work. It only doesn't have to work for one of them. So that is not going to work. Don't automatically assume that if the negative one is there, then it's going to be the one the one you're getting rid of. If we had some kind of a thing where like log was like, 7 minus p, then the 10 wouldn't work and the 5 would, because you'd have minus a minus and it turn it back into a plus. So don't just automatically assume, well, the negative one is out. Don't do that. You have to check them. Okay. But since we checked, we have our solution set is 10, and we're all set. Okay, so that's how you solve a logarithmic equation. This is my favorite flavor of logarithmic equations. So if you ever have me for a class or you're wondering what possible fiendish thing can I come up with, this is the fiendish thing I came up with. Okay, so I'll let you go with that. Good luck, and I will see you in a little bit.